While starting with Lewis dot pictures of atoms worked well for homonuclear diatomic molecules, it doesn't work nearly as well for heteronuclear diatomic molecules, where the two atoms are different, or for larger molecules. For those, we'll need a more reliable method, and if we're willing to stick to the octet rule, there's a straightforward way for us to draw Lewis structures correctly. And it starts with finding the number of shared pairs in a molecule ahead of time. In finding the number of shared pairs in a molecule, we can use the simple algebraic relationship Sp equals 1/2 of Er minus Ve. Sp is the number of shared pairs in the molecule. Er is the number of electrons required to give each atom in the molecule an octet in the absence of bonding. This is as though the atoms were acquiring an octet by gaining electrons to form an anion. For the purposes of Er, hydrogen atoms would only want 2 electrons, not 8. If there are no hydrogen atoms, Er will be a multiple of 8. Ve is the number of valence electrons actually present in the molecule. We can find the number of valence electrons in each atom from its location or group number on the periodic table. We should always find that Er is greater than Ve. As in life, molecules find that what they want, Er, is always more than what they have, Ve. Let's try a few examples. First, the dinitrogen molecule. There are 2 atoms each wanting 8 electrons, so Er is 2 times 8, or 16. A check of the periodic table finds nitrogen in group 5a. Each nitrogen atom has 5 valence electrons, so Ve is 2 times 5, or 10. Substituting into the equation for shared pairs, we find Er minus Ve equals 6. There is a deficit of 6 electrons, or 3 pairs of electrons. There are 3 shared pairs in this molecule. For carbon dioxide, there are 3 atoms, each wanting an octet, so Er is 3 times 8, or 24. Carbon is in group 4a and oxygen is in group 6a, so Ve is 4 plus 6, or 16. Substituting into the equation for shared pairs, we find Er minus Ve equals 8. There is a deficit of 8 electrons, or 4 pairs of electrons. There are 4 shared pairs in this molecule. When hydrogen atoms are present, as in ammonia, Er may not be a multiple of 8. One nitrogen atom wants 8 electrons, but each hydrogen only wants 2. Er is 8 plus 3 times 2, or 14 electrons. Nitrogen is in group 5a, while hydrogen is in group 1a. Ve is 5 plus 3 times 1, or 8 electrons. Using the equation for Sp, Er minus Ve equals 6. There is a deficit of 6 electrons, or 3 shared pairs in the molecule. In summary, Er is the number of electrons required to give octets, or duets to hydrogen, in the absence of bonding. Ve is the actual number of valence electrons available. The difference is the deficit of electrons, which leads to the number of shared pairs.